Okay, I want to keep taking small steps as we work with fibers. So this is another small example that we have here. And let's just start at the top here. So I'm creating this variable named background task. And what I do here is I say, do a sleep for 1 second. And then, if you call this operator, the and then operator, and then print this line that the background task has completed. So sleep for a second, print the line background task completed. Now we come down to our application here inside the run value. And the first thing I do is take that background task and then I fork it, and that creates a new fiber. Then what I do is I say sleep for 700 milliseconds and then print hello. And then on the third line, I do a similar thing, sleep for another 700 milliseconds and then print world. So the quiz for you is, what does this code do? And a very strong hint I can give you is that I'm not doing a join operation here. So if you're ready, we'll come over here and run that and take a look at that. And I hope this is what you guessed, because the way this works is background task is forked, and that means it runs on another fiber. So you can think of that as now running on this fiber over here, a separate fiber. And that's going to sleep for 1 second on that separate fiber over there. And now over here on our main fiber, the code comes down to the next step, which is the second one right here. And it says sleep on the main fiber for 700 milliseconds and then print hello. So now you can think of this fiber is running and it's going to sleep for a second. This one is sleeping for 700 milliseconds, so it's going to win that race. It's going to print hello, and that's what happens first. As soon as that is printed, the main fiber over here, you can think of that as going on to the next step. But the next step says go ahead and sleep for another 700 milliseconds. So during this time, during the second sleep time, this 1 second process finishes, and that's when background task completed is printed. So this is at the 700 millisecond mark, this is at the 1 second mark, and now this is going to be at 1.4 seconds when this highlighted line of code finishes right there. So that's how this code works, and as usual, give me just a moment and I'll bring up a visual diagram to show that as well. So here we go with the visual. Again, the code starts at 0. First thing that happens is we fork this background task, and that starts running over here in this background fiber, and the first thing it does is it starts sleeping for 1000 milliseconds or 1 second, so that's going to be sleeping over here. Then we come back to the main fiber, and it jumps down and it says, okay, I want to sleep for 700 milliseconds, then print hello. So at the 700 millisecond mark, that's what happens right here. It prints hello. Then, as I mentioned, this line of code starts running, the third line in the for expression. I don't show that very well here, but the third line starts running right here. And now we have a race essentially between this print statement and this one. So at the 1000 millisecond mark, the background task prints on the background fiber. And technically that brings the background fiber to an end at that point. And I should show that here, so why don't we do that? So that does bring that to an end. Notice that I don't rejoin the main fiber because I don't have a join statement up here. So we can just think of this background fiber as ending right there. So it printed at the 1000 millisecond mark. Then the next one prints here at the 1400 millisecond mark, and then we reach the end of the application. So if you haven't used threads or fibers before, I hope that showing both the code here and then showing a little bit of a visual representation of how that code works is helpful. And one other thing I want to do as far as extra credit right here is show how that join would work. So now I'm going to call that fiber background. So a good question at this point is, can you remember what we did to join the fiber in a previous example? And I half gave that away. But what we do is we just say that we want to join that background fiber like that. And before I press save, again, I'll ask you to think about, now what do you think is going to happen now that I do this join right here? We start this new fiber here, then we say, I want to join that fiber, and then we have this other code here like we did before. Okay, so if you've thought about that, I'm going to press save. And there you go. The background task prints first, then hello and world. And no matter how many times I run that, we are always going to get that same result over here. And the reason for that, I don't have a diagram for this one because I just thought about showing this. The reason for this is because this one starts on another fiber, but then we say, hey, we're going to wait right here and we're going to join that fiber when it ends. So you can think of this as just waiting right here. It's going la, 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 la. Then 1,000 milliseconds go by, it prints and it ends. And then you can think of us joining that, and then this line of code runs, and then the next line of code runs after that. So join right here is a way of saying, yeah, sure, go ahead and fork that and run it on another fiber over here. But we're going to sit right here on our main fiber and wait until that's done before we go on to this next step and then that next step right here.